I will be teaching you about the history of the periodic table.
My name is Alex, and I will be teaching you how the elements of the periodic table are arranged.
My name is Jackson. I'll be teaching you about dot structure diagrams. Now on to Logan.
Thanks. I was just out here surrounded by the elements. It all began in 1789 when Antoine Lavoisier published a list of 33 chemical elements. These were grouped into gases, non-metals, metals, and earths. It then evolved into Mendeleev's version of the table in 1869, adding new elements and spaces for future elements, which were all grouped by atomic mass. It was later updated by Mendeleev to group them based on characteristics.
There are 118 synthetic and natural elements on the periodic table and counting. They are arranged into periods, which are rows, and groups, which are columns, hence the name, the periodic table. There are 8 major groups of elements, and they include the alkaline metals, the alkaline earth metals, halogens, noble gases, metalloids, transition metals, intertransition metals, and nonmetals. On the periodic table, you will come across many of these small squares, each of which has an abundance of information on the atoms of each individual element. For example, the 1 to 3 large letters that you see inside the square are known as the atomic symbol, which helps us to better identify each element. The number above the symbol is known as the atomic number, or the number of protons that each element has in its atom. And the number below the name is the average atomic mass of the element.
Here in the periodic table of the elements, we have different groups, which are basically these columns here. Okay, so this is column 1, 2, 3, 4, 5, 6, 7, and 8. And what these show are the number of valence electrons, which is the number of electrons in the outermost shell. We're going to have a quick example on how this dot structure diagram works. So what we're going to do, we're going to take an element from the first column, let's say sodium down here, and we're going to take one from the 7th column, chlorine. So in this first column, it means they have one extra electron, which means they have one valence electron. So they want to give that one away so they can have finished the rule of octet, which means they have 8 in their outermost shell. And chlorine needs an electron because it's in the 7th. It needs to make 8. And so chlorine wants that electron. So what we're going to do is we're going to draw it with this structure diagram. Okay, so we're going to draw chlorine first. And we're going to go 1, 2, 3, 4, 5, 6, 7. And that's the 7 valence electrons that chlorine has. Then we're going to sodium, which is 1. And what we have here is a bond. And that bond, so these are sharing the electrons, making it so this one gives up its 1 valence electron so it can have the rule of octet in its lower shell. And this one, in chlorine, has 8 electrons in its outermost shell. So they're all happy, and that's what we call a bond.